This is Algebra 2.6, and the lesson starts on page 100 in your book. So our lesson is going to be about distributive property. And for example, if you go shopping and you wanted to buy a bunch of CDs, I don't know how many kids nowadays go buy CDs, but anyhow, you want to go buy a bunch of CDs to, let's say Christmas CDs, so you can play a bunch of Christmas music. You can use estimation or mental math to determine the total cost. For example, if you wanted to buy, 10 CDs and they were $10 a piece, that one's an easy one. It's going to cost you about $100, but you can estimate. So that noise that just came rumbling in was Maddie and Caleb coming in from band practice very noisily. So anyhow, that's what that was. So with the distributive property, we're going to use geometry as an example using area model. And we can look at this first box. Let's just pretend for the sake that I guess I haven't had enough caffeine to do two boxes that are exactly the same size on here, so I apologize. But we're going to pretend that they're the same size for this lesson. And so we have a box here, and then I have part of it proportioned off here. And so we know that area is length times width. And we know right here that we have a measurement of 3. So the width is 3 here. And the length here is x plus 2 to go from this all the way to here. This whole thing is x plus 2. Over here on this model right here, I marked it a little bit differently. So we have the x right here and the 2 part. So you can see that there's x and there's 2. And so we can write it out two different ways. We can say area equals 3, which is the width, times x plus 2. We can also say area equals 3 times x plus 3 times 2. Both of these are right. The expressions represent the exact same area, and they're true. So this is a perfect demonstration of the distributive property. We can distribute it differently and get the same answer. Now for this example, we have the width is 7, the length is 3 plus x, and I could write this two different ways. I could write 7 times 3 plus x. I could also write it 21 plus 7x. So those are two ways that I could distribute this using the area model. If I wanted to write an algebraic statement that showed that the two expressions that I had just written on the previous slide were equal, I would write it like this, the equal sign here, and this way. And so it shows that the two different equations are equal. So just to go over the distributive property, it allows us to get rid of the parentheses by bringing a multiplication from the outside to inside a parentheses. So it allows us to distribute in the equation. So in the first example, we have a times b plus c equals ab plus ac, and b plus c times a equals ba and CA. So here you can see it's pulling it out, in this case, of the parentheses. The same you can do, that was with a subtraction problem. You have AB, or A times B minus C, and there you pull them out. Same over here on this side. So they're pulling it out of the parentheses so we can solve the problem. So what we want to do now is to use the distributive property with addition. On my example A here, I have 2 times x plus 5. And so the first thing we want to do is to distribute the 2 to each term of the x plus 5. So that would give us 2x plus 2, 5. And now we can multiply, and that would give us 2x plus 10. Over here on the B side, we want to distribute the number 8. So we would have 1, 8 plus 2n times 8. Then we're going to multiply, and we would end up with 16n. So it's 8 plus 16n. So in this case, we use the distributive property with addition. We distributed the number, in this case the 2 and the 8, to each term of the, in this case the x, the 5, the 1, and the 2n, and then we multiplied out.